Good afternoon and welcome. I'm Brent Donaldson, Editor-in-Chief for Modern Machine Shop. Today's webinar, brought to you by Rapid Robotics, has been designed to help manufacturers at every scale solve their labor shortages, see ROI, and win new business. Today, you'll learn about Robotics as a Service, or RaaS, a flexible, scalable, full-service automation solution that removes traditional barriers to robotic adoption. Of course, not all RaaS providers are created equal, and today you'll learn what a true RaaS solution should offer, how to identify the best robotics partner for your business, and how implementing robotic automation with a RaaS partner can position your business for growth. Today, we'll discuss what's included in a true RaaS offering, how RaaS makes robotic automation easier to implement and more accessible for manufacturers, and how RaaS makes manufacturers more resilient, more profitable, and ready to grow. Presenting these and several other topics today is Kim Losey, Chief Marketing Officer for Rapid Robotics, as well as a serial entrepreneur and business designer with a passion for manufacturing, marketing, and leading high growth businesses. Kim has led global teams responsible for the growth of some of the world's most well known toy and entertainment brands, built an award winning omnichannel retail business, and was part of the founding team of Modio Inc., which Autodesk acquired in 2014. At Autodesk, Kim led the marketing teams responsible for emerging products, acquisitions, and growth, including Fusion 360, expanding on years of manufacturing expertise. Please note, audience members, that you can submit your questions about today's topic at any time during this presentation. Just type your questions in the questions box and we'll answer as many as we can at the end. Also note that this webinar is being recorded and you will receive a link to that recording via email. So without further ado, let's get into it. Kim, please take it away.
Hello. Hi, everybody. I wish I could see everyone that was here on the call, but thanks for joining us this morning. I think that, or this afternoon, robotics as a service is a topic that we're hearing more and more about in the news. Just a couple of headlines here. But as you mentioned, I've spent a lot of time with the Gartner team and with Modern Machine Shop and all the work that I did at Autodesk in leading the Fusion 360 marketing team and our advanced manufacturing portfolio. So I have a special place in my heart for a machine shop and trying to help, find ways that we can help it grow. So I wanted to share with you kind of what we're hearing about robotics as a service, walk you through what robotics as a service is not, and then talk to you about what we think you really should be looking for, and the questions that you should be asking in a partner as you're looking at robotics. So perhaps you're here because you're really curious about robotics as a service, or maybe you're here because Gartner puts out great content, or maybe you're here because you really do have a severe labor shortage, which is something that we're hearing more and more and more about. So I don't know if you're probably all feeling this very much in your own shops, depending on where you're located. But here's some numbers behind it. So the U.S. labor shortage today is estimated to be 865,000. That's unfilled machine operator positions. And the average machine operator is 48 years old. So that seems not too scary, except that for every 10 machine operators that retire, one new person comes into the workforce in that space. And there are a lot of cool people out there doing a lot to try to change that, to change the perception of manufacturing and to actually show what a technology-driven industry it is becoming. But we still have a long way to go. So you can see the chart on the right in terms of automation, the US is really trailing the world. And I think some of the reasons for this is that the cost has been really high. There's been not a lot of flexibility, especially for higher mix environments. And I think that, in a traditional capital expenditure model, you guys are spending hundreds of thousands of dollars on CNC equipment. And, you have some amazingly skilled machine operators that love what they do. So maybe it hasn't been the first thought to move to robotics. But the kind of bad news is we think that this labor shortage is just going to get worse. So a number of sources are citing that there are going to be 4 million new workers needed in the manufacturing industry between now and 2030. And potentially 47% of those jobs are going to go unfilled. So that leaves a huge gap, one that actually has an impact at a GDP level, potentially $1 trillion impact to the US. So we've got to do something. And we all want to see our businesses grow and honestly keep our people happier. What we're finding is, machine shops, companies really that are embracing technology, that are embracing robotics, are attracting new talent. They're a fun place to work. Our friend Andrew Crow says, the screenagers, they're on screens today. You want them as your workforce of the future, you need technology in your facility. So we want to talk to you a little bit about ways that you can do that, maybe with fewer barriers than there have been in the past. And that's really what robotics as a service is. So here's what it is not. When you think about robotics as a service, you want to think about software as a service is really how this originated. So it's not one and done. A robotics as a service provider, you should think of them as a long-term partner. If you're not making money and you're not successful with your robot, we also are not successful and you can send it back. So we don't want that to happen. So you want to make sure that, again, that you're thinking about partnership, not one and done. It's also not a lease. So there have been companies out there that are talking about robotics as a service, whether it's an hourly model, business model, or, different ways that you might pay for it. It's way more than that. There's an important service component. So this is not just I pay for my robot and after 3 years I own it. It is truly an ongoing service, which we'll talk more about. It's also not risky. The traditional process of automation has been risky. This huge capital expenditure up front. A lot of times you get a robot, a lot of people don't realize how complicated it is to program. How do you actually get it to integrate with the other machines and the equipment that you've got? When something goes wrong, how much does it actually require, to change it? And sometimes people will feel that they have some new talent, automation engineers maybe that are, fresh out of school. They want to invest in some of their own robots. And then the challenge can be those people move on and then you're kind of stuck with it. And we find what we see as the robot graveyard. So robotics as a service eliminates some of that risk. And it also doesn't have to be it doesn't have to be complex. So robotics as a service providers really strive to provide the simplest, fastest solution. And they don't have to be single purpose. So that traditional large robot that you bolt to the floor that doesn't have any flexibility, robots as a service can provide more flexibility by design or through ongoing consultation. Okay, so let's dive into all of those things a little bit more. And as I said, our team's here in the background too, capturing questions. So if you have questions as we go, please feel free, ask them and I'll be happy to answer them in the end. So robotics as a service truly is a partnership. You want to think about whether it's us or any other provider as a long-term automation partner and an extension really of your engineering team. So the process, when we come in to look at an automation opportunity, we often get, whether it's an inquiry on our website or people from a webinar that say, I'm considering robotic automation. I'd like it to do whatever, machine loading or machine tending. Sometimes it's, laser etching, some of these secondary operations. And so we'll go in and we'll say, look, let's walk through the factory, show us what you're trying to accomplish. So there is this consultative approach. And we try to think about bottoms up transformation or bottoms up automation. How can you start with the simple things where you're going to see the fastest deployment and the fastest return on your investment? And then you can sort of get increasingly invested in automation once you start to see what works. And many of you may have started your businesses in this way. Start with a Haas machine, and then all of a sudden you're bringing in a bunch of other machines, and then you've got a whole huge business. So you can think about robotics in the same way, and you want to think about solution seeking, not necessarily in terms of I need to automate this one task, because if it's hard for a human, it tends to be hard for a robot too. But there are other operations that can more easily be automated that can free up that human labor to do the more complicated, actually more rewarding things. And we do try to be very ROI focused. We want you to be instantly successful and instantly seeing that return on your money. Okay, so the next thing, operating expense versus a capital expense. One of the things that we hear a lot is, I don't want to lease my robot. I don't want to rent my robot. I buy equipment. Just fair. We have a lot of thoughts on sort of what are some of the challenges with that. But the thing, and then other people will say, I don't know, how do I pay for it? For 40 years, I've been working in this OpEx model. I, depreciate my asset, and I don't know how to handle this, a capital or an operating expense sort of model, which would be, so robotics as a service, taking just a step back, you pay monthly. So there is sort of a setup fee and then a monthly or an annual subscription, and you can pay it monthly, quarterly, or annually. So the way there you can think about it is the same way you pay an employee or an employee. So you would hire a shop technician or somebody who would run one specific operation. You could hire a robot in this case with robotics as a service in exactly the same way. And you want to think about, it shows up, it's pre-trained, it knows what it's doing, it gets to work on day one. There isn't that steep learning curve necessarily that you sometimes have with a human operator. And then you can pay it just like you pay a human monthly, whatever the price may be. So there's zero upfront cost. There's instant return on your investment, and it really reduces your risk. So you can see there's the robot graveyard. And then the chart on the right is really intended to show the cost over 10 years. So with a robotics as a service kind of model, you could, depending on the complexity of your deployment, you are paying an annual fee. It could be $30,000. It could be $55,000. It kind of depends on the robot and the complexity of the project. But then when you start to look at a traditional capital expense solution, if you're buying the equipment, you're bringing in all these systems integrators and specialists to be able to do it, you're looking somewhere at the $1.2 million range. And then if you compare that to human labor, you have a much higher cost. So some of the things to think about. We talked about flexibility. Robotics as a service providers, we win through long-term success, and flexibility really is built into the robots as a service deployment, and that's by design. So this video that we're showing here this was one of our early robots in its rapid machine operator cell. It's rolling over to a pad printer. I think it was doing a pick and place operation before this, rolling over to a pad printer. We're touching 3 buttons on an iPad there. It's got a camera attached to it. It scans a fiducial marker on the pad printer, and then it instantly recalibrates itself and can get to work on that new task. So that's what smart task identification, simplified automation design, and then what we call smart setup. So the thing I want to mention here too around simplified automation design is I've heard a lot of stories where people will have an automation proposal from maybe a traditional systems integrator, and they'll have a lot of upstream or downstream modifications that they need to make that can get really, really expensive. And there are ways that we come in, or any robotics as a service provider really should be coming in and helping you to look at, how do I drive down that cost? Can I create a fixture that will bring the robots, or that the robot can pick up from, that's a fixed spot? It doesn't have to be coming down a conveyor in all sorts of different ways that make it really hard to pick up, or really fast, or really unpredictable. There are ways to be able to structure that kind of stuff very inexpensively. So you want to really ask those kinds of questions. How do we drive down this cost? Are there things that I could change in my upstream or downstream process that would make this simpler? So that's a little bit about flexibility. The next is around streamline deployment. So rapid robotics, for us, it really is built into the name. It's really about speed, and we do think the rate at which robots today are being deployed, because of all these barriers, is not enough to keep up with the growing labor shortage. So we're trying to find all the ways we can to be able to improve and speed up that velocity of deployment. And with a robotics as a service model, we don't get paid until your robot's working. So speed for us is also essential. We do a lot of work with digital simulation. It's very similar to the same way you can, validate your tool path. You can see a collision coming. The same thing happens as we're programming robots virtually. We're then also 3D printing our end of arm tooling. So you kind of think about sometimes 3D printing, maybe not those of you who are doing secondary operations on metal prints, but we think about 3D printing as prototyping. We're really using it for production. A lot of our components have 80/20. There's 80/20 in those end of arm tools, plus carbon filament. And that allows us to create the kind of accuracy we need and the flexibility that we need for these end of arm tools. I think the one that you have a picture of here on the screen, I think, is picking up copper sheets, and it had to pick up 18 different sizes. So there are creative ways there that you get that flexibility to be able to handle maybe not super high mix, but a number of different types of parts. So you can get creative with that end of arm tool, especially if it's not off the shelf. So custom tool, and we do think about it in this modular approach sort of way. Okay, cloud connected scale. So I remember, I don't know, 8 years ago maybe, when we the Fusion 360 business, everything I heard all the time, I don't want to move to the cloud. I know that there are still a lot of challenges with that in certain industries, but I think COVID has changed a lot of that. And what we find with robotics as a service, there's a huge advantage to having your fleet cloud connected. You get the advantage of your software always being up to date, kind of obvious. You get new capabilities that are very easy to deploy, but the most important thing really is cloud-based performance monitoring. And support. If you're in a high production environment and something goes wrong, you don't have 5 days to wait for somebody to come out and see your shop and figure out what's wrong with your robot. You need to know instantly. And so we're able to remote in to your robots, generally 98% of the time within 30 minutes, certainly less than an hour. We can have the problem resolved and you can be back up and running. The other 2%, where we've run into issues, we're able to diagnose the issue remotely. We can see maybe it's a joint that's gone bad in your robot, or I don't know, there could be something else that's happened. We can see a lot of that and rule certain things out remotely so that when we get on site, we can instantly either repair it or swap out your robot. We have done that for a customer before. We think that it was a joint issue. We retrained quickly a robot in our facility. I think that one might have been in Novi, Michigan. And then within the next shift, we had that out and swapped, and the customer was back up and running. So you really want to think about this, advantage of being able to see what's going on and fix it fast. And then unwavering support. So, I've probably said this too many times already, but RaaS really it's about this partnership, and it removes the burden of ownership, providing that always on support so that you get maximum utilization and minimal downtime. You get the 24/7 support, you get remote diagnostics and correction, and then on-site immediate remediation. I think this is one too that I guess I would say, as there's more and more talk about robotics as a service, I think that's where the important piece really comes in, the service component, and really reinforces, it's not just about financing a robot. And I think that we've already kind of touched on this, but just as a reminder, why it's critical to start automating now is it is that labor shortage. It's projected to get so much more significant. And then when you stop to think about, the average annual wage increase for machine operators, and we're hearing stories of turnover rates that are astounding. And again, this may not be as severe. You have highly skilled, highly talented machine operators, machine programmers. But in the broader manufacturing space, when we're thinking about the lower skilled machine operator labor, it is tough. And here's a little bit about us. So we've been in business since 2019. We have robots. We turned 3 in the fall. We have customers who've been running their RMOs continuously for more than 1,000 days. We're deploying dozens of rapid machine operators a month. We have teams of experts in San Francisco, as well as Michigan, Texas, Massachusetts, and teams throughout the US. So we do try to make sure that we have account executives and field application engineers throughout the United States, so we can get wherever we need to go within the next shift. If something were to go wrong and we need to solve it on site, we'll be ready. Quality is a big application, for robots. Quality approved production parts, saving customers millions of dollars, and we are backed by some of the world's largest VC firms. And I think that is, in summary, that's what we've got for you all today. I hope that there are questions. I know we have a lot of time. I'm certainly happy to dive into any of those things a little bit further, or answer any other questions that you all may have.
All right. Thank you, Kim. And this is just a reminder to those of you who are listening live that right now is the time to ask any questions that you might have. Just go to the Q&A section at the top right of your screen and type in any questions that you might have for Kim, and we'll try to get to them. We do have a couple in the queue here. Okay, Kim, can you please give an example of the flexibility that you're talking about? There are folks who have experience with robots and cobots that need to be programmed for very specific tasks. Is that what we're talking about here?
I think so. I think yes. So I think, well, let me take a step back. Yes, I think that I can give you some examples of the flexibility and the tasks. They are, with the flexibility, we do program them. So we program them to those specific tasks. And then when we deploy them on your site, they don't need to be reprogrammed. So there it really just becomes through that fiducial marker that you can, I'll say, redeploy that robot to its next task. So where that would be possible, I think, is if it's, like the video we had the robot, it was doing a pad printing, or it was doing a pick and place operation, pulling key cards off of a conveyor and stacking them. And then it was taking them from that. We moved the stack and went over to a pad printer and rolled the robot over. And then the robot was picking it up from the stack and putting it into the pad printer and then onto a conveyor. So in that case, it still had the same, that gripper was the same, but it was doing different tasks with the component. I suspect what the question might be focused on, certainly in the machine shop, there's a lot of precision that's required and often variety in parts. So how might you move from one task to the other? I think in that case, what we would do is, work with our customer to understand, or prospect to understand what operations you're looking to do. We then we program that robot to do those things. And then when we deploy it on your site, we can test it to make sure that it's working in those different environments and that it's set up so that you're literally only, or you or your shop operator are working on that simple 3-button touch screen. So you can reset it. You can choose which of the tasks you want it to do at any given time. You press that task, it scans to know its position, and then you press start and it gets to work.
That's really cool. So I visit a lot of machine shops and I see a lot of robots and cobots being used. And my favorite operation is, no matter what kind of complex task these robots are doing, is when they are programmed to shut the machine tool door and actually press the start button. It's awesome. I just love it. All right, we've got some more questions rolling in here. What is the maximum weight that can be handled by your robots?
It's a great question. So we work with Universal Robots and we work with Yaskawa Robots. So today we can go up to, with one of our, we have the Yaskawa, I think it's a GP25, up to 25 kilograms. So it can get quite heavy. Originally, we were only working with the orange cobot that you saw in the video, and that had a payload, I think, of 9 pounds, maybe. I think that's one of the other advantages of the end of arm tooling being custom printed is that really helps us manage the weight so that you can put more weight into the parts. But there is restrictions, and certainly, or for the robots that we have deployed so far. There are companies out there and that are using also this robotics as a service model that do integrate with other bigger robots with a higher payload and a larger reach. So they would be able to, probably manage whether it's, big raw materials or large sheets, things like that.
Yep. Okay. Next question from Jeremy. Jeremy is asking, how can robots and cobots be used in a quality inspection type of role?
Great question. Yes. So there are a lot of vision systems that are out there. And as we think about a solution and a rapid machine operator, we don't make the robots ourselves. Like I said, we work with UR and Yaskawa. Just like those partners, we also work with vision system partners, Cognex and Keyence and Elementary. There are a number of them. And we'll find the right solution to help you achieve what you're trying to achieve with inspection. And we can, again, the whole system sort of shows up pre-trained and ready to work. So we have some customers. One example is there's a customer who is he's building, I think, parts to a GPS system. And he's only running one shift, maybe 1.5 shifts in his shop. So it was really like, I don't know, does automation make sense for me? It's traditionally been so expensive. And what he started to realize is when he shipped something out, it was all being inspected by humans. And we all know that with things like inspection, humans aren't the best and they get really tired. And as they get more tired, their inspection capability gets worse and worse. So the robot has been really helpful for him because he's now no longer getting back those entire cases of expensive product that was basically being scrapped and rejected by the end customer. So you can do a special, like a very simple, the robot can pick something up, it can put it into the inspection station, sort of the camera, inspect it, and then direct it into like approved or a not approved sort of format. We've also seen this with Kiehl's makeup jars, one of the production facilities that makes makeup jars. We do an inspection line where things will come down the conveyor. They come into a sort of gate. They pass through the inspection camera on the conveyor into the gate where it gangs them into, I think, 7. And then there's a gripper that sort of grabs all 7 and picks them up and moves them to another conveyor line where they kind of continue. So we try to make all of that as seamless as possible. And then that's where it gets complicated. I think it's not that hard, I guess, to program a simple cobot. But then when you start thinking about integrating it with the vision system and the conveyor system and all of those other things, and how does that trigger the light that tells you that it's approved, whatever those things are, it gets complicated. So you want to think about a robotics as a service provider as someone that you can literally be just say, here's what I want to accomplish, make it happen. And they make it happen. And then they don't just make it happen, they make it happen and they keep it happening, which I think is really critical.
Very good. All right, questions are rolling in here. We've got one from Rick, followed by a separate question from Jeremy. Rick asks, how do you address the concern from existing employees that they will be replaced by a robot?
I know, it's a good question. I think starting early, actually, in where we've seen success is having customers that have started early and bringing the employees in the process. Help to understand what is it that they hate to do and help them see what they'll be able to do when the robot comes. Because in every case, I've seen the employees get trained on, I mean, I know upskilled seems like such a buzzword, but in every case, they've been moved to something else. They're too valuable to be sent away. And so they always get to do something better. We have a story that somehow comes up in every conversation about Mr. Fu, who for 25 years was sitting there inspecting this one part at a medical device production facility. And now Mr. Fu is actually managing 4 different robots that are all doing that job, and he's kind of keeping an eye on them. And when something goes wrong, he knows how to quickly fix it or how to call us to get it to get readjusted. But he's learned a lot, and he's not doing this terrible repetitive job chained to his desk for 8 hours a shift. I think the other thing, an interesting story, we have a Barron's. Barron's is a metal pail manufacturer in Wisconsin. They were a customer. They have 4 rapid machine operators. They also have a very large robotic installation. So they started with the large robot project, and halfway through, I think it was taking a long time. They needed some other things. They brought Rapid in. We came in and solved the opportunity for them they were punching holes in the metal bucket. The turnover was terrible. It was hot and dangerous work. And there were a number of workers on the line, and they were first skeptical, and then they were interested in what was happening. And then the robots were deployed and they were working. And one of the operators got mad because he felt that the robot was slower than he was, which was true. But what the robot did is the other 5 workers further down the line weren't as fast as this first worker. And so the robot began pacing the line and actually sped up these workers. And then they increased their whole line throughput by 40%. And over time, then everybody starts to love the robots. They appreciate that the robots are making their jobs easier, and they realize they're not being taken away. Another maybe tip, something cool that some of our customers have done that I find really fun, is they engage their customers, or they engage their employees in naming the robots. So the robots truly become coworkers. We have West Tech Plastics. Tammy Barris is the president there, and she has 3 robots. She's named them Kim, Nancy, and Melvin. So the employees will come back and they report like, oh, Melvin has, there's been a hiccup with Melvin. He's doing this weird thing on the box. We need to get him adjusted. So it's kind of, I think it makes them feel more human, and the employees like them.
That's funny. I've been to Bilstein, the famous manufacturer of high-end shock absorbers for cars, and they have tons of cobots around, and they name them after U.S. presidents.
Oh, that's funny.
They've got dozens of them. I don't know, I think they're up through maybe Johnson or something like that. And just to tag on what you were saying, Kim, I've also, in my experience, I've literally never been to a shop where employees were laid off because they brought a cobot on. Instead, it's exactly like you were saying. Those employees with lower skilled tasks are often put in charge of running the cobots and robots, and then their job title changes to something like robotics supervisor or something cool like that. It's a total upgrade. All right, next question, back to Jeremy. He's asking, what is the usual lead time from contact to implementation?
I love that question. It depends. It has been as low as a number of weeks, less than a month. Traditional automation, we did a study across 303 manufacturers at the end of last year. I think 75% of robotic deployments actually take longer than 9 months. So we have been able to do them in weeks. Our goal is to be able to continue to do them in weeks. Depending on the complexity of the project, it could be more like 2, 3, 4 months. But you should be able to do it within a quarter. I think it also depends on, I forget exactly how you asked the question, like project signing to project deployment can be very fast. The process, as many of you know, depending on the size of the company, can be a little more challenging to get to that from concept to actual sign. But let me talk a little bit about how we think about the process too, and set your expectations, hopefully in a good way, what you should be expecting from any supplier. We try to come on site as fast as possible. As soon as you're willing to meet with us, we'd love to come see your factory. We then walk through, try to understand what you're seeing or what your goals are. We can talk about what's relatively easy to automate. We usually find 4 or 5 tasks and say, these would be perfect. Let's start there. We go away, and within a week, we have a proposal for you. It includes a whole CAD model of what the cell would look like. Once that works, then we actually go to pre-training and the simulation of the robot, and then we get you the whole automation proposal. So usually all that is total 2 weeks. You can then, depending again on sign off, but then the robot is basically, the virtual training work is done. We start to assemble the cell either in our facility in San Francisco or in Michigan. It gets shipped out, it arrives on your floor, and then from the day it arrives and we set it up, it's usually 4 to 6 hours.
All right. Hayden is asking, how many different tasks can be stored on a single robot?
That's a great question. I don't know how to answer that, to be honest. I think a lot of it depends on how similar they are. So it would be very hard for a robot to be doing, you can't, unlike a CNC machine, it's not that easy on the robots to just swap out the end of, the tools. There's no automatic tool changer for the UR10, for example, not that I know of anyway. So you could swap it out, but you want to think about how might we even build one for you that has, I don't know, 2 to 3 different gripper components, so that maybe if you're using one side of it, it's doing, some sort of gripping motion, and then it rotates, and on the other side, it's doing, something. So you wouldn't have to swap out that end of arm tool. It would be very hard to go from having a robot that's doing, this is maybe extreme, but like welding, which we don't really do, to pad printing, for example. Like you kind of need things that are similar-ish. But I think a lot of the different task could be accomplished with a smart, cleverly built end of arm tool. But I do think there probably is a limitation. 2 is easily doable, I would say. 3, 4 is also probably doable. I think by the time you get beyond that, it gets pretty tricky.
All right, we've got a good question here coming from Chuck. Chuck asks, do you also perform any required integration with the machine tool?
We can provide some integration with the machine tool. We certainly want to make sure that the robot is up and running. So we would do all of that and make sure that your system is, I guess, completely integrated. I think there are some machines that are very hard to integrate because they're very old. We integrated into a 1980 something pad printer pretty effectively. And then there's more modern equipment where it's much easier, but certainly we would assume that would be part of our responsibility in getting your robot up and running.
Karen is asking, if you do all of the programming in advance, can your system be used as machine tending if we're running different parts on the machine every day?
Yeah, I don't know how that would work. It would be, it would have to know what parts you're running on the machine every day, or have some sort of something to register, like a consistent, I don't know what it would be necessarily, if there's a consistent diameter of the stock that was being put in there. I think it would have to have some consistency, or it would require kind of constant reprogramming.
One option might be, if these are, it sounds like we're talking about machine parts. If you machine some kind of a little fixture, leave a little tab or something on the part that's going to be in the same location spot every day. I could imagine that as a possibility.
That is a possibility. Yeah, that could work.
Good question. Jason is asking, can you give an example when you've turned away a potential customer from the RaaS model? It seems like there are few downsides. Are there any downsides?
We we'll turn away a customer if we can't do the job, if we don't know we can do the job. I think that's where you get the no risk, right? Where I'm not going to tell you I can do something if we can't, because we don't, we have a lot of other things we need to do. We don't want to do something that's going to fail, and we don't want to lose your trust as a customer. So there are things, there are often also projects that people come to us with, I don't know, that are really complicated. They want us to do something with, wire and harness and lots of, spools of different things. And it just is, it's hard. If it's hard for a human to do that work, it's hard for a robot to do that work. And so we tend to not do that. We try to be able to connect people with people we do know that do specialize in those areas. We're part of A3, the Association for Advancing Automation, and the NAM, a number of trade organizations. We're either members of them or on the board. So we're trying to build these relationships so that we can advise you. If it's not something we can do, then we want to be able to help you find the people who can do it for you. In terms of other downside, I would say that I don't particularly think there's a lot of downside, but there are a lot of people who still are uncomfortable with the service model, and they do still want to buy their robots. And I think I understand certainly the appeal of owning the equipment, especially if it's something you're really used to. But I think the important thing, we actually have a paper on this that we can also share. It's important to think about the true cost of ownership. And when you buy a robot, you're just buying the robot arm. You're not buying the safety equipment. This is the traditional model. With Rapid, everything comes inclusive. But with a normal capital expenditure purchase, you're buying the robot, but then you also have to think about the safety equipment. And the end of arm tool can cost easily $10,000. And then you think about the programming, and then you think about the support, and you need to think about the lifespan of the robot and how many cycle hours it's really projected to be supported through. And with robotics as a service, you don't have to worry about any of that. It just works. So I think that's where the risk is that people don't always want to change how they've done things, and they still have, it feels almost too good to be true. And I think that's hard sometimes to overcome.
Eric is hoping that we can revisit the topic that you covered briefly in your presentation about cost comparisons. He's interested in, you mentioned that human operator costs rapidly escalated. And he's asking if you can share the cost comparisons and what you typically see in terms of ROI and payback.
Sure. So the way we think about, well, I guess how do we want to start this? So let's use a Rapid. If we start with Rapid and a standard simple deployment, there is a one-time setup fee. Let's just say for an average complexity project with a average size cobot, $35,000 for a setup fee that gets your robot up and running, and then it's $35,000 a year. So the way we think about that, and it could be less, could be more. Again, depends on a number of factors and how complex with the vision systems and all these things. But then we sort of think about, you can take that, in the first year. So then you're looking at $70,000. What is the labor equivalent? Certainly that the ROI is not there likely if you're only running one shift. If you're running multiple shifts, then the return on investment does seem to be there. But then in year two, you don't have that setup fee, so you're only looking at the $35,000 a year. And that's where, we try to help customers think through, okay, well, what is your, how many shifts are you running? If it's one shift, 50 weeks a year, you have 2,000 hours. If it's two shifts, if it's three shifts, then you're kind of looking at 6,000 hours. And then you want to think about your human labor. I think this is where it gets very tricky, is when you look at really your cost of human labor. It's easy to understand, of course, a base pay, let's say, I don't know, $18, $20 an hour. It's easy to understand what you pay for benefits. And we sometimes then think about our fully burdened cost at that. but we're not necessarily also thinking about the safety training and certifications that we need to have for our employees and for the cost of being able to recruiting. Sorry, hold on. The cost of being able of recruiting, the cost of downtime, the additional overtime that you're paying for other shifts for people to be able to come in. I think that those all really start to add up. So we often encourage people too that are exploring robotics as a service and in a larger organization where you feel that there are many stakeholders in the decision process. Sometimes it's helpful to bring in your HR business partner, your recruiting team, even your finance team to be able to look at some of those numbers up front so you fully understand what am I really paying in human labor so that I can understand what my flexibility is in terms of robot prices or robot labor.
Related question here from Jeremy. Is the monthly cost inclusive of everything, meaning tooling, maintenance, servicing, etc.?
Everything, yes. What may not be, if let's use an example of if you needed a new conveyor system, maybe something that we don't really provide, we would integrate into your conveyor system, but there we would just either buy it for you and pass on the direct cost to you or let you buy it yourself. We can advise on which component to buy. But everything that is within the Rapid Machine Operator, fully supported 24/7 and for the duration of your subscription, which is generally 2 to 3 years.
Very good. I think we just have one more question, and it is also related to cost. Can you just talk a little bit more about kind of making the argument that Rapid is cheaper over the long term? This person is saying that they would have assumed that owning the hardware would be cheaper after a certain period of time.
Yeah, I think, I certainly think we should share it. It could be. I mean, I think that it does depend. But I think when we interview most of these customers and through the manufacturing survey and other research that we've done, by the time you buy the robot and you buy the end of arm tooling and you buy the caging and then you buy the maintenance support and then you wait for the systems integrator. Now, if you're integrating it yourself, that might be a different story. But if you're then hiring a systems integrator to be able to come in and do the project, if you can get them, because often they have a high threshold for what they're willing to be able to, what's worth their time. You add on that, and that can be, I can't remember what the numbers were, but often more than $100,000 that you're paying for that systems integration. And then if you decide that the robot needs to be adjusted or if something goes wrong and it needs to be retrained and you're bringing that person in again. So it really is it's just with RaaS or robotics as a service, it's predictable. There is no, you know exactly what it's going to be and you know that it's going to keep running. And if you own the equipment, it just becomes, there's that compounding cost. And every time something happens, then you're waiting. There's the time element and then the cost element to have somebody come out and fix it and buy that new end of arm tool or whatever it is that needs to be replaced.
Very good, Kim. That was great. Is there an email address where people can? There you go. There's a link to contact. I do encourage everyone to check out rapidrobotics.com to learn more. In the meantime, thank you so much, Kim. Thanks to Rapid Robotics for making this webinar possible. And thanks to everyone for listening in. You should receive an email with a link to the recording soon. So that's it, everybody. Thanks so much. Thanks for your time and enjoy the rest of your day.
Thanks, everybody.